In this video, we are tasked to write and assemble a program to load values into each registers R20 to R24. And then we are also tasked to push each of these registers into the stack. And we will utilize the single step program. We will examine the stack as well as the SP register after the execution of each instruction. So we are given the code that is already present in the description below. Check it out. So now let's proceed. Let's create a new project. Select Atmel AVR Assembler, and we will rename this project as L7 or Laboratory 7 Activity 1 since this is our first task. In this part, we will just try to set the file location or the path of the file that we are going to make. Let's click next, and then we will choose AVR Simulator, and then we will choose the device at Mega 32 since it is the required for us, and then click finish. Let's wait for the IDE to load. So here's our IDE. Let me just try to adjust this one since we will be needing more space for our assembly code. And I will just try to type the codes in here and trying to examine the code as we debug later on. And also take note that this code has been already provided to us. Just only check the description below. And now, since we are done with our writing of our codes, we will now try to assemble this code for us to verify if there are existing errors or there are no existing errors within this code. And fortunately, we did not encounter any errors, as you can see. And then we were able to proceed to the debug mode or assemble and run and build. Let us just wait for it to load successfully. And now we are in the debugging mode. So let me adjust this one since we will be needing more space to see the actions and some changes. So here's our stock pointer. We can monitor it in here. And then here's our registers. We can scroll it down to see our registers. On the right part of our IDE, we can click this CPU, and then we can monitor our stock pointer register here, in which we can see the SPH and the SPL as well as the hexadecimal values and their addresses. So now we will proceed to our single step for us to observe and examine our registers and stock pointers. So in the first step, it is observable that the stock pointer doesn't change values. But after the first out instruction, it is observable that the stock pointer has altered the values. And as we do expect, the second out instruction will also give changes in our stock pointer. In the LDI instructions, there are no significant changes in our stock pointers. But in our registers, there is. Since we are loading values into each register, and we will later on see them on the latter part of this video. And for our push instruction, after the first push instruction, it is observable that the value is decrementing. And for our second push instruction, it is observable that the value has been changed, decremented from 085E to 085D. Same goes for our third push instruction wherein it is decremented from 085D to 085C. Also, same goes for our fourth push instruction. And for our last push instruction, it is observable that the value is decremented from 085B to 085A. And now we will try to monitor and examine our registers. As you can see, the values from R20 to R24, all of the values are starting from 0. But as we load the values with the LDI instructions, it alters the value, Just like in our first LDI instruction, it is observable that as we load values into R20, it changes from 0 to 5F. And the idea goes on with our preceding LDI instructions. But as we come across with the push instruction, there are no significant changes with the values of our registers. So maybe that's it for the examining of our SP and registers. And in this part, we can also monitor our status register. We can scroll down to verify our flags. And as you can see, we can check out and monitor them all, minimize and maximize this one. And I guess that's it. And that's all for the first problem. Thank you for watching this video.